Good afternoon, everybody. Thank you for joining us today. We're going to talk about some really interesting new features that we're coming out with over the next 6 months around change data capture. So my name is Jay Hurst. For those of you I have not met, I am a product manager here at Salesforce. I sit in our data and events area, which includes enterprise API, platform events, and these new set of features around change data capture. With me, we have Larry Chan. Larry is one of the lead developers on our change data capture product, and he's going to be helping me today doing the demo. And now we get to see the obligatory forward-looking statements slide. I'm sure you guys have seen it. This is probably the one you've seen more than anything else. But if you are making any purchasing decisions, please make those decisions based on what is generally available in the Salesforce product and not what is considered future and forward-looking technology. Everything we're going to be talking about today is under this forward-looking statement. It is all forward-looking. It is not currently available. Please keep that in mind. If you are thinking about purchasing, do not purchase based on anything I tell you today. If we come back in 6 months, that will be a different story, hopefully. But what we're going to do is talk a little bit about what change data capture itself is, how we have customers currently managing change data capture in Salesforce. We're going to describe what we think of as a complete feature set around change data capture, and we'll give you a demo of what we currently have working internally and give you an idea of what it will look at. And we'll definitely try and leave some time for Q&A. But first, what is change data capture? How many people have heard of change data capture? All right, you're all in the right area. Those of you who have not seen it or don't know about it, you can read the Wikipedia article. It's very engaging. But essentially the idea is, how do you begin to capture state changes that happen in one data set? So if you think of this in Salesforce, how do I know when somebody edited my account and changed the name on it? How do I know when somebody created a new lead? How do I know when somebody did something else? So CDC, or change data capture, allows you to get the information when that piece of data has changed. In Salesforce, this is creating, updating, deleting and undeleting records. And essentially you can use this to help keep your systems that are external to Salesforce in sync with the data that's in Salesforce. And this is really the challenge problem set that we see a lot of customers have, which is, unfortunately, Salesforce, for one reason or another, is not your master data management system. We realize that that's the state of most of our enterprise organizations, but you still need to be able to make sure that it has the latest data, and vice versa, your other systems have the latest data from Salesforce. And so that becomes very challenging. But what does this mean in the easiest form that I can put it in slides? You have an account. When you create that account, it goes into the Salesforce database. You want to get a change event over to your database so that you can create that account in your external database. Then when we go ahead and update that account from Acme to Acme 2, you want a new event that goes over so that you can go ahead and see Acme 2 in your database. Pretty simple. The idea is mimicking data in multiple places. And this is generally a very difficult problem to solve. There's a lot of moving pieces, as you can imagine. Now, we have a number of ways you can begin to get there today with Salesforce. This is what customers do today. This is a challenge problem that everybody has had. But there's a number of ways you can start to solve this. The first is using SOCL. How many here have used SOCL or heard of SOCL? Everybody, perfect, you're all experts then. But what SOCL is our SQL-like query language. It gives you the ability to programmatically access your data and retrieve the state of the data in the system as it exists at the time of request. There's a lot of good things about this. You can use this across any Salesforce org. It's a very common language. The data is available in multiple formats. You can get the data back in JSON, in XML, in CSV. We support a lot of different file formats there. And it is retrieved on demand. When you need it, you ask for it, and we give it back to you. However, there are a number of challenges with it, specifically around large data volumes. When you start to get tens of millions of records in your database, how do you get them all out in a way that's fast and also gives you a sense that you have the up-to-date information? It's also really hard to capture granular changes. So since you only get the data when you request it, if somebody makes 10 changes to that data in between your requesting times, you only get the state at the end. You don't get kind of a tracked change history. And it's up to you as a client to retain some state so that you know what is the next query I need to run, so you can kind of step through. We also have a replication API. This is an API that has been around for about 16 years. How many of you have actually heard of the replication API? All right, that's about how many I thought. There's two calls in the replication API, and you have probably heard of these. It's get updated and get deleted. But the idea is to essentially pass in a start time and an end time and have Salesforce give you the IDs back of any record that was updated or deleted in that time frame. It's very easy to use. It gives you back a large number of records when you request. You can get up to 600,000 records per retrieval, and it is retrieved on demand. But it starts to become a little difficult to use, just like Sockle, because you have to do multiple requests in order to get the data. You first have to get all the IDs, and then you have to query for those IDs. It's still hard to capture those granular changes, same as the Sockle. You have to keep that state still the last time you ran it. And there is some issues around long-running transactions, where if a transaction takes a couple minutes to run, you can get into a weird out-of-sync mode. So it's not a perfect bulletproof solution. We also have the streaming API. How many have heard of that? Great. So streaming API is kind of the foundation of what we've built a lot of platform events and change data capture on top of. But the streaming API is essentially, you define a Sockle query, you say, anytime data matches this query, go ahead and send that data out to me. So you are in control of the definition, which makes it very useful. The push topic events themselves are sent near real time, which means when you make that change, you should get that change within a couple of seconds, which is great for capturing those granularity of changes. But there are some limitations around things like how many objects you can do this on. There's only about 8 or 9 objects that support streaming today, which is a low number. It has a very low query limit of 1,300 characters, so it's very hard to say, give me all of the data of this record. And if you have a lot of Apex triggers, you can get into weird states where you receive updates before you receive creates, and it's really hard to get a transactional or ordered nature of what happened to your data. And finally, we have the Platform Events API. This is what we released just summer 17. It really allows you to get much more granular and to send this data out. You manage the capture logic. You create when the event gets sent, so you have full control over that. They're sent near real time in under a couple seconds, and the granular changes can definitely be captured. However, because you have to define it, you have to define it. That means that it's up to you to trigger when changes happen. You have to compare records before and after using trigger.old and trigger.new. It's very time-consuming in the developer landscape. So there's also not all operations can have a trigger, so there's certain tables you cannot trigger off of, and because you cannot trigger off of it, you cannot emit a platform event. And there are significantly lower limits to platform events compared to some of the other features. So the endscape that we have really is that there are a number of ways to do this, and you can get very close to a change data capture solution today using a combination of these, using replication API with streaming API in order to give you hints on when to query, using bulk API for a day zero extract, things like that. But it doesn't really solve the problem in a way that makes it very easy for customers. So our goal with change data capture is to give you essentially a fire hose channel that will allow you to get every change that happens in the system at near real time just pushed to you automatically without you having to do any coding around it. We want to additionally guarantee order of these events so you can completely reconstruct what happened to your data. And we want to support every object in the system so that you can get a complete picture of what happens in Salesforce. The way we're looking at it now, we also give you a lot of other information that isn't necessarily data specific, but more around the transaction specific nature, such as where did this call originate from? Was it a Salesforce API that made the call? Was it a customer's API? Was it a partner's API that made the change? We tell you, here is the entire transaction ID so that you can start to say, all of these changes were wrapped up in a single transaction, so I can determine if I need to do special logic around that. And then we tell you what the exact operation was. We can tell you, was this an update? Was it a create? Was it a delete? Was it an undelete? Was it a convert, et cetera, things like that. So the anatomy of a change data event is kind of fairly straightforward. If you have played with platform events at all, or if you've looked at the streaming API, this will start to look fairly familiar. But the first thing we have is we have the name of the event channel. Now, we have this one channel that we're looking at here, /data/change events, and this is the fire hose. This will give you everything that we are currently streaming to you in one. We also have virtual channels that you can drop down if you only want specific changes. Say I only want lead change events. We have a virtual channel you can subscribe to that is /lead change event or /account change event, where you can just say, I only need these specific set of changes. Next, we have a schema. And this is where we start to see the platform events and what some of the big value adds here. With the schema, we can actually tell you at the time of send, what did the schema of your data look like? This gives you the ability to manage not just the data changes, but to start track metadata changes as well. With this schema ID, you can go to the REST API, you can plug it in, and it'll give you the exact layout of what that record looked like at the time of this event. As you change an account, let's say I add a new field type to it, I create a new custom field, that will change the schema. Every event associated with the account then will have a new schema ID. And we retain these things in perpetuity so you can start to see changes tracked over time. We have event replay information. This is so that you can actually go back and replay events. So if I want to replay something from the last 24 hours, for instance. Now we have this change event header, and this is where you get all of that extra additional information, so you can start pivoting on different things. So here we see entity name, we see what change type it was. This one was a create of the accounts. We see what the ID is of that. Change origin is, we see that this was changed by com.salesforce.core, so this was a core Salesforce code that was, or change that was made probably through the UI. We have the transaction key and sequence number. If that transaction actually had to do 4 or 5 things, you'd see the sequence number change for each of the events. Is the transaction completed? And nulled fields, which will give you a list of anything that has been nulled. And finally, we have the actual data that changed. In this case, I am showing I changed the billing address on the create, and I set the name in the website and some ... other stuff. Is everybody with me so far? Yes, thumbs up? All right, good. So now I'm going to turn it over to Larry. Larry's going to give us an actual live working demo. This is against our internal code base, so we're running against Winter 17. We're going to be showing you in Aloha because there's some very interesting changes that are going on to the Lightning UI that I cannot show you yet officially. So this will work in Lightning as well. It's kind of UI non-specific, but just take that in mind. As we're going through that, and with that, Larry, take it away.
Okay. My name is Larry Chan. I am a software engineer in the Change Data Capture team. And what I'm going to show you today is straight from the laboratory how Change Data Capture is going to work. And thanks for the forward-looking statement. So I'm safe here. So on the left-hand side, we have our Salesforce org running as normal. But on the right-hand side, what I have is a small little program that is going to listen to all the change events. So if you look at the command line that I have there, I actually pointed to the org. So it's my local host. This is the username. This is the password. And I'm actually listening to /data/change events. That means I'm listening to all the change events from this particular org. So as you can see, I actually did an experiment before the demo. I already have a change that's happening. So right now, I'm actually just listening to the tip of the change. So as change are happening, they're going to be streamed into the client real time. So let's go into the demo. Let's create a lead. So let's say Ken Jacobs. Hope he's not here. It's a real person. And he works for, no, Jacobs. So Jacobs. So Jacobs company, and phone number, let's say 123 456 7890. So let's just give that. And so you can see that change event is coming. I have the lead create in the header. So it shows you that this is a lead being created, and it shows you all the data that comes with the lead create that I have. So for example, in this case, I have the first name Ken, last name Jacobs, and I have also all these metadata, transaction ID, commit timestamp, and the ID of the object. So let's do a lead convert. So this would actually demonstrate that it actually works as a transaction because lead convert actually creates an account an opportunity, and also updates the lead to convert it as well. So you can actually see that in one transaction, you have actually multiple changes and how we can capture it. So let's do a conversion. So I'm going to say this is an opportunity, 1,000 widgets. I'm going to also create a task. So task is call Ken, and let's give it a due date, tomorrow. So, and then let's say convert. So what's happening is in our app itself, we actually have all these database triggers running in Oracle that's capturing all the changes, listening to all the changes. And also, we have a asynchronous process called the drain pump that's actually pumping through all the changes captured by the trigger and streaming it to the backend delivery system. And eventually, the subscriber is going to realize that there are changes that are happening and pull all these change events out from that delivery system. So as you can see, we have just captured an account create. And you can see that this is like sequence number 1. So in a lead convert, the first thing it does is it creates an account. And you can see that the sequence number is 2. And this is actually creating the contact itself, which is Ken Jacobs in this case. And then the third thing that it's doing is creating an opportunity. So the opportunity is created as part of the lead convert. And this is, at last, is converted. So you might ask, what happened to the task that I created? So since this is the laboratory, we haven't made it to the task yet. It will be coming. So the task is actually something that we are not capturing today, at least in this lab. So
real quick with that.
Sorry?
So one of the things that was hidden there that was really interesting is also the way we do our ordering. So this is very important. We need to make sure that we're delivering out to you events in the order that they occurred, especially if they're occurring through different users, at different times through different APIs or through the UI. So while the change happened very quickly there, we actually have that asynchronous process that runs. There is a delay where we order and reorder everything inside of those transaction boundaries, and then we push them out. So while this is near real time, it's not going to be at the same 1 or 2 second level that streaming is. It's going to edge more towards the 10 to 15 second delay right now, which is still much better than we can get across the board, and we will be working to drive that down. But I definitely wanted to highlight that because there's a lot of complexity that's being hidden from you in this, and which is what we want, but it's also good to know how we're doing this in long term.
OK, so now we have the account. So let's update a few things and see what happened. So for example, here, I'm going to do a jacobs.com, just update the website. And so one thing that you have probably noticed already is that when we actually give you the change event, we only give you the fields that are relevant. We only give you the fields that are changed. So in this particular case, I only updated the website. So you can see that only the website field is present in the change event. So we don't give you like names and phone numbers anymore because those are not the data that you have changed. So in this case, the payload is actually very small if you have small changes, versus if you have a huge update, then you're actually going to get more fields.
And this is key because as you start to think about your entire user base doing this, for those of you that have thousands or tens of thousands of users and you're doing hundreds of thousands of changes per day, it starts to add up very quickly when you think about the number of bytes physically going across the pipe in your listener. And if we're capturing all of the data and sending you every bit of data, even that hasn't changed, you're talking about sending hundreds of megs of extra data that is essentially wasted on that. So we're really focused on tuning these to make them as efficient as possible.
Right. So let's add it Ken, the contact. So let's give it a phone number, a mobile phone number. And save it again. We should be able to actually see that only the phone number has changed. And yes, indeed, only the mobile phone number has changed, and this actually is captured in the change data capture event. So we have the opportunity now. So let's say a sales actually talked to Ken, and he came back, and he actually know that this deal is going to worth $110,000. And you can see that the amount is updated in real time, and we also capture it correctly. So let's do something more destructive. So let's say I'm going to delete the account. So this will actually lead to a cascade delete of the account, the contact, and all the opportunities that we have created. So you can also see that in the delete, account is deleted. We also have the account ID. Contact is deleted. We have the contact ID. And also the opportunity is deleted. And we have the opportunity ID. So if you are only deleting the account, you might think that, oh, how do you capture all these different changes? So that's why, as Jay has said before, this is actually pretty complex that's occurring behind the scene right now to actually deal with all these cascade delete. Also, you can undelete. So if you go to the recycle bin now, you will see that I have just deleted Jacob's company. If you undelete, all three is going to come back. So, yep. So actually, when you undelete, you actually get all the data back. Not only all the data back, but you also get all the data that's before the delete. So for example, this is the opportunity that you have undeleted, and you can actually see that the amount is also right there that I have updated. And you can see that you have Ken Jacobs coming back, and also you have your account that's being undeleted as well. So you might say, oh, OK, accounts, all these opportunities, they're standard objects. You know how to do them. How about custom objects? I have a custom object that I have the fields, and I have the different data types. Can you handle it? And the answer is yes. I have just created a course object before the demo. So for example, this is a course, let's say, Physics 101, and this Feynman, 5 credits. So you can see that custom object is right there. So you have credit. You also have the instructor, Feynman. And you have the custom object ID coming. So this is a small demo, but I hope that it's very useful for you. So before I go, I think what I want to also show you is how do I capture these change events. So if you look at this command that I have right here, it's running something, right? So we actually have an open source kind of like a subscriber, an example subscriber that you can actually download from the GitHub. This is called a dev login example. So look at this. I have only written 61 lines of code to actually have this program running, capturing the events in real time. So if you look at it, very simple. Pretty much all you need to do is you define like a callback, what happened when the event happens. So when you have an event, what you do is you actually convert it to a JSON by using the JSON library. And then you just say system.out, and then print out the JSON payload that represent the event itself. We are using very simple things like, for example, login. So we have a login helper that is already provided for you. All you need to do is provide the server, which in this case is arg0, username is arg1, and password is arg2. And of course, you need to give it the topic, which is argv3, I guess. So it all matches what I have here. So /data/change events would be what you're subscribing. If you want to have multiple subscriptions, you can fire up, you can create multiple of these EMP connectors. You don't need to write any line of code in the EMP connector is provided for you. All you need to do is give it the login, and then give it what channel you want to subscribe. I think Jay earlier also touched on the topic that what if I don't want all the events? What if I only want for example, lead event. So what you do here is you switch your channels from change events, which listens to all change data captures, to only lead change event. Also, you'll notice that in the event itself, you might wonder what this replay ID is. So what this replay ID does for you is, if your subscriber ever dies, you might, for like a few minutes or maybe even for a few hours, where you're actually going to lose the changes in between. So if you want to make your subscriber resilient, you can actually remember what is the last replay ID you've seen. And then once your subscriber goes up from the crash, you can actually say, I am subscribing from that replay ID, and all the events from that replay ID afterwards is going to be streamed to you. Also, if you actually just want to listen for all the events like within 24 hours, what you can do is there's a special replay ID called -2. So if you do -2, what's going to happen is it's going to stream you all the events starting from now and back 24 hours. So you can see that, for example, in this particular case, we have just converted the lead. And this is the lead update event that we saw. This is the lead create. So remember, Ken Jacobs, and also all the data that I did earlier before the demo. So I, of course, did that other lead create. And you can see that everything is just a lead. So for that, I'm going to hand it back to Jay.
Perfect. Thank you so much, Larry. Let's give him a round of applause, everybody. And so with that, what does our roadmap look like? So with Summer 17, we're in an internal-only pilot. We're doing a lot of demos internally. We're actually starting to use this across the board for our various features, things like how do we seed the Einstein data lake so it can actually start learning about things that you're doing. Well, we're going to be doing it with change data capture. At Dreamforce, my goal is to get this to a pilot, start taking customers in to actually use this. We're looking at having roughly 20 entities supported, one of those being all custom objects as well. Having the ability to enable change event capture through the metadata. Supporting 2 formats, JSON like we saw today, also Avro minimal format so that we can actually start to really get good throughput there. As we look out towards spring, bringing change data capture to beta, start ramping up how many entities we support, and this is really going to be kind of the long tail with change data captures. How long will it take us to cover all of the entities? Fortunately, it's not. We couldn't find the easy button, but we're in the process of building one. And then actually getting to an admin enablement through the UI, not just the metadata API, and topic filtering. Topic filtering being things like, if I wanted to subscribe to the account change event channel, but I only wanted to get the events that apply to a certain number of accounts, only subscribe to that, being able to filter the channel and subscribe. So with that, we have about 2 minutes for Q&A, and then we can also do something later. So maybe take 2 or 3 here. So that question is, do we have an in-transaction level flag that indicates whether we send it all out? Everything has a transaction ID in our system. It's all Oracle-based, so we do. We don't have a specific flag enabled for you to hook into by any means, but that's how we're driving a lot of that transactional tracking that you see. Right here. So the 2 questions were, how is this going to be available? Is it available to everybody? We don't have pricing and packaging yet. I would assume that this is a add-on feature, although we haven't discussed it yet. We're still way beyond, way far for that. The second question was, how does this compare to field history tracking? Field history tracking is all about storing the history of your fields on Salesforce. This is about how do you get the Salesforce changes outside. So they are complementary, different use cases depending on what you wanted. But with this, you could build a very extensive field archiving or field history tracking outside of Salesforce. So, but it just depends on what you need it for. I think we have one more right here. Say that again, sorry. Yep. So the question is this about does it manage or handle bulkified transactions? It does. The way we do bulkification transactions in Salesforce, everything actually goes into 200 save layer, 200 records in our save layer. So you're never going to be able to get 5,000 in one transaction itself, but it will handle up to the 200 that we allow. So with that, I have 5 seconds left. We're coming right in that time. Thank you guys so much. We will be here to answer any other questions for a few minutes, and we can take it offline as well. But thank you for joining us. I hope you enjoyed your Trailhead DX experience this year, and have safe trips home.